Imagine throwing a baseball, kicking a soccer ball, or shooting a water gun. That object, once it leaves your hand or the gun, is a projectile. So, a plane flying isn't a projectile, not in the classic physics sense. A projectile is any object moving through the air, only under the influence of two things: its initial push, the force that launched it, and gravity, pulling it down. We ignore things like wind resistance for simplicity, which is why a feather floating down wouldn't follow the classic curve. But a golf ball hit off a tee. Perfect projectile. The path it takes is a beautiful curve called a parabola. The trick to understanding projectiles is realizing that its motion has a split personality. We separate its movement into two totally independent parts: horizontal motion, left and right, and vertical motion, up and down. Independent, like two different movies playing at once? Exactly. The speed that moves it left and right doesn't affect the speed that moves it up and down, and vice versa. Gravity only works on the vertical motion. Let's focus on the horizontal side, the left-right movement. We call the speed in this direction the horizontal component of velocity. Why does it stay the same from the moment the object launches until it hits the ground? Is it because no one is pushing it anymore? That's right. Think about forces. According to Newton's second law, an object's velocity only changes if there's an unbalanced force acting on it. In the vertical direction, we have a huge, constant force, gravity. This force is always pulling it down, which is why the vertical speed is always changing. It slows down on the way up, stops at the peak, and speeds up on the way down. But in the horizontal direction, after the initial launch, what force is pushing it forward? None. Remember, we're ignoring air resistance. Since there is no horizontal force acting on the projectile, there is no horizontal acceleration. If there's no acceleration, the horizontal speed, the horizontal component of velocity, must remain constant throughout the entire flight. Imagine pushing a shopping cart on a perfectly flat, frictionless surface. Once you stop pushing, it keeps going at the same speed forever. That's the projectile's horizontal motion. So, a cannonball launched horizontally will travel the same distance in the first second as it does in the last second, even as gravity is making it plummet faster and faster to the ground. The two motions are completely separate.